Creating reflections inside of Unreal Engine can be achieved in a number of different ways, and each way has its pros and cons. Let's have a look at 3 of the different ways to achieve high-quality reflections in Unreal. We'll start with the most affordable method, which is to use a cube map to generate our reflections. But before we do, one thing we want to make sure of is that we have a material surface that is ready to accept reflections. In the map here, we have a large mirror surface, and if we select it and look under the materials, element 0 has a reflective surface. Let's open it up. Looking at our material instance, we can clearly see that we have a very chrome-like or mirror-like surface here. And this is being driven by 2 values, metallic and roughness. If we look at the parameters on the right, we can see that the metallic value is set to 1, and the roughness min and max are both set to 0, making this a very smooth, reflective surface. We're going to find the different reflection actors on our modes panel under visual effects. The first ones we're going to look at are for generating a cube map based reflection. And those are going to be our sphere reflection capture actor, as well as the box reflection capture actor. The box reflection actor tends to work well for cube or rectangle shaped interiors. For this tutorial, we'll stick with using spherical reflection capture actors. Keep in mind that spherical reflections will have some spherical distortion or warping in the actual reflection. Before we add the actors, let's talk a bit about the pros and cons of using reflection capture actors and discuss a good strategy for placing them. Reflection capture actors are static, meaning the cube maps they generate are calculated when the map's lights are built. They have very little performance impact at runtime. However, if you use too many that overlap, this can cause significant overdraw at runtime, as Unreal blends overlapping reflection actors together. Also, capture actors that have a very large influence radius will incur a greater cost as they cover more screen space. To help improve the reflection environment quality and to help avoid performance issues, use a hierarchical layout of your reflection actors. In this case, we're going to place one spherical actor in the center of the map and set the influence radius to encompass the entire map. Next, we'll place smaller reflection actors that will cover each room. Finally, we can place the smallest reflection actors near details, such as the glasses on the table here, in front of the TV, and in front of the mirror. The influence radius determines the priority of each reflection actor. Smaller values take priority over larger ones. We can reduce or increase the quality of the generated cube maps in the project settings. Simply search for reflection. Take note of the reflection in the mirror as I tweak the resolution. At a higher resolution, the reflection gets sharper. Lowering the resolution, we can see it gets much blurrier. Keep in mind that when you increase the cube map resolution, you're increasing the amount of texture memory required by the video card. Due to the inherent distortions in cube map based reflections, they may not always be the right choice, such as for something like this large flat surface, this mirror here. However, for other objects such as these pieces of glassware here and this silverware, reflections from a cube map may be just fine. But when you need a more realistic reflection for a large surface such as this mirror, we can make use of another technique. We'll discuss that technique as well as screen space reflections next time.